We open up our session to all of you here with us. As we learn more about this upcoming program, you can see here on your screen, we're going to be talking about computer vision, learn the fundamentals of computer vision and its applications. So this course is provided by Carnegie Mellon University, the SCS Executive Education. We're going to be speaking a little bit more about this learning community that you're joining here at Carnegie Mellon. But as we make our way through the presentation, we're going to be touching on two main themes here. As you think about this program, we're going to be telling you what you'll be learning in this course, what is the curriculum, how is it unfolding, and what you'll be learning in terms of your goals and objectives from week to week. So we'll be talking about what you'll be learning. We're also going to describe how you'll be learning. So we're going to be talking about the ways in which this program is delivered to ensure that you have the very best learning experience. So as we make our way through this next hour, stay tuned for more information about this program, about what you'll be learning, as well as how you'll be learning it. I'm going to introduce to you today's speakers so you can learn who's on the line. From there, we're going to talk about Carnegie Mellon School of Computer Science, this larger ecosystem of learning that you're joining here today. You'll learn more about your program faculty, their areas of expertise and research. And then from there, we'll do a program overview. So this will be a detailed curriculum overview where you'll get an understanding of exactly what we're going to be doing in the program. And then from there, we'll talk about the program experience. That's how the program is delivered. What is that day-to-day feeling like in the course? So a lot to cover here today. Let's go ahead and kickstart the show here by introducing our speakers. Firstly, we have with us Chris Kitani. He's an associate research professor at the Robotics Institute, a courtesy professor of electrical and computer engineering at the School of Computer Science, Carnegie Mellon University. Professor Kitani, would you like to jump in and say hello to our audience today?
Yep. Hello, everybody. This is Chris. I'm really excited to be here today, and thank you all for joining. I'm really excited to talk about what we're going to be covering in this course with Giannis today. So I'll be back in a few moments.
Thank you so much. That is a teaser of what's to come. We're going to hear more from Professor Kitani here in just a moment. He's joined by his co-collaborator and colleague, Professor Giannis Goulekas, who is an assistant professor of robotics at the Robotics Institute at the School of Computer Science at Carnegie Mellon University. Professor Goulekas, would you like to jump in and say hello to our audience today as well?
Yes, of course. Hello, everybody. Like Chris, I'm very excited to be here, and we'll talk more about both what I'm doing and the course that Chris and I will be teaching in a few minutes.
Thank you so much as well for being here. And finally, we are joined here by the Director of Executive Education at the School of Computer Science, Ram Kunduru. Thank you, Ram, for being here as well. Would you like to jump in and say hello?
Thank you, Marie. Hi, everyone. Thank you for being here. I'll quickly go over some other deep tech programs that we have in a little bit. Welcome.
Thank you again, Ram, for being here. So with that, let's go ahead and tell you more about this community that you're joining at Carnegie Mellon School of Computer Science, which really is recognized and respected across the globe as a center for unparalleled research and education in computer science. And the reason for this is it's a home to world-class faculty, as you'll see here today, learning from our professors, faculty who help offer undergraduate and graduate education and research opportunities that are unparalleled, second to none, along with executive education programs such as this one here that are designed for today's professionals who work in a variety of technical leadership roles. So you really have this target audience as we think about who these programs are designed for. We know that you are all working professionals, and so we hope to showcase for you here today how we have that in mind in the development of this program. So SCS is known for being at the forefront, setting the course for advanced computer science discipline, including artificial intelligence, computational biology, human-computer interaction, language technologies, machine learnings, robotics, and software research. So certainly this interdisciplinary approach, cross-collaboration, as they bring together these themes under this umbrella at Carnegie Mellon. What you can expect here, expertise from instructors, integration, the ability, again, to have interconnected learning modules that leverage all of these resources and these different areas of expertise. And then finally, of course, its reputation precedes it as a global leader in academic research. So so this many of you already know. So I'm going to hand over the spotlight now to Ram to tell us more about Carnegie Mellon, some upcoming programs and opportunities. You can see here he's the Director of Executive Education. His team manages online and on-site custom and open enrollment executive education programs within 7 departments here. So he's really looking across the span of these different areas as he thinks about executive education programs. His focus is on expanding global access to SCS's world-renowned faculty and their expert knowledge. And of course, that's what we're doing here today by bringing this program to all of you from across the globe. So Ram, thanks again for being here with us today. I'm going to hand over the spotlight to you for the next couple of slides.
Thank you, Marie. Am I able to advance the slides? Okay. We'll get into the details of the computer vision program in a little bit. As Marie was mentioning earlier, all of our deep tech programs, they run for 10 weeks. We have content developed by the professors with quizzes, assignments, and projects and what have you, and you get a certificate at the end of the 10 weeks upon successful completion of the course. In addition to computer vision, as you can see on the screen, we have various programs in different stages of launch. We launched a deep tech course in machine learning, which is on the 4th run right now. We have a programming in Python course that is launching as we speak. Obviously, computer vision, natural language processing, deep learning will be launching in the first quarter of next year. And in December, we're going to be launching our courses in Introduction to Artificial Intelligence. One of the next slide, please. In addition to individuals such as yourself, if you belong to the learning and development departments of companies, if there is about 20 students or more that enroll in the same run of our program, we are able to provide dedicated teaching assistants that will provide live office hours, live online office hours, so that your colleagues will have the freedom to discuss challenges, opportunities, and what have you, without worrying about confidentiality. And we provide tiered discounts for companies if there is interest. And you'll have all that information on our executive education website, which is exec.cs.cmu.edu. Next slide, please. At this point, I'd like to turn it over to Professor Yanis.
Thanks, Ram. Hello again, everyone. So I'm Yanis Koulekas. I've been at Carnegie Mellon University since 2017, coming here from Harvard, where I did my PhD, and then before that from Athens, Greece, where I did my diploma in engineering. So I work broadly in computer vision and in computer graphics, and specifically within these areas, I focus on designing new types of sensors for doing stuff like 3D imaging, imaging below the skin, imaging around corners, as well as developing physics-based models for computer vision algorithms. So we'll cover a lot of these topics throughout this course when the corresponding models will be taught by me. Chris, you want to go next?
Sure. Hi, everybody. Again, this is Chris Kitani, and I have been at the Robotics Institute at Carnegie Mellon for about 10 years now, and I've been working in the area of computer vision for about 15 years. I did my PhD at the University of Tokyo. I also did my master's degree there, and been faculty here at CMU since graduating. I do have some industrial working experience. I worked in the semiconductor industry, working on machine vision for defect inspection for several years in Silicon Valley and in Japan. And so, I really understand some of the practical needs of computer vision and, how that works out when you actually have a product. My research currently, it is at the intersection of first-person vision. So you could think of wearable cameras, AR, VR perception for those kind of systems, human activity modeling, and also inverse reinforcement learning and sequential decision-making in general. So in addition to teaching the computer vision class, I also teach the statistical techniques and robotics class at CMU. I work mostly in the area of visual cognition. And in this course, I'll actually talk more about the different fields of computer vision, but visual cognition is probably one of the biggest areas right now with a lot of research happening in that area. So I will be talking about that a lot when we go into the different modules for this course. And I also have a lot of applied research in the area of personal and assistive robotics, using computer vision to help blind people navigate indoors, surveillance and security. And also I've been doing a lot of work with autonomous driving companies using perception for autonomous driving. So good. So that's a little bit about my background. I think what we're going to do now is switch into the program overview. I'm going to talk a little bit about what we'll cover in the course at the high level, who should attend, some of the key takeaways that you might expect to get, and then we'll dig into the different modules. All right, so let's talk about the course overview. So really what we want to do is we want you all to be able to learn the fundamentals of computer vision. So what we've been seeing recently with the increased digitization across all industries, people and companies are just consuming more and more image information more than ever before. You know, the hours of videos being uploaded and images being shared is just astronomical. So what happens is when we have all of that data, we're asking ourselves, okay, what can we do with this? You know, with all of these pictures we've captured with our mobile phones or medical scans that you might take at a doctor's office, right? Well, how are we going to process all of this? So computer vision is a key technology that's going to be needed to process through all of this data, right? So this need for processing images and documents, any kind of digital information is just popping up everywhere. So because of this, we've had this increased demand for technology professionals that have in-depth knowledge about computer vision and who are able to apply it in different areas of industry. So what this program is going to do is it's going to help you to have a really good big picture of what computer vision is about, and also dig into some of the various topics, understand the theory, and to understand the algorithms. Now, in order to be well prepared for this class, the program is going to require that you have some knowledge of linear algebra, calculus, probability, and statistics. So, you know, don't let these words kind of scare you. What we're looking for is just a solid math background that you would get, you know, in an advanced high school class. I mean, I think that's what we're looking for. The participants should be comfortable with Python programming. If you are not, there is another course on programming in Python, which might be of interest to you. And the programming assignments that we're going to provide to you are based off of programming assignments that graduate students and undergraduate students at CMU are actually working on. I think really give you a chance to dig into some of these algorithms and help you to understand how these technologies can be used. All right, so let's go to the next slide about who should attend. Though I guess we did talk about this a little bit. So this program is designed, it's ideal for technology professionals. So this is going to be including machine learning engineers and maybe even computer vision or image processing engineers that are working industry and you're looking for kind of a refresher. This is going to be a hands-on experience with computer vision tools. You'll learn about the different techniques and you'll really learn how you can use these techniques for real-world problems. You're going to be focusing on the skills that you're going to need to address different problems in motion and structure, visual cognition, computational photography, and 3D reconstruction. Another target will be software developers and technology professionals who really just want to gain a deeper understanding of computer vision and use this as a stepping stone to advance their careers with a certificate from our CMU, taught by CMU faculty. Data science and data analytics, machine learning professionals who are looking to improve their knowledge of computer vision technologies. So you might understand, the underlying machine learning behind some of these methods, but maybe you don't have too much exposure to actually working with images and working with camera information and video. So those are the type of people that I think would make a good fit for this class. Okay. The next one is going to be the key takeaway, what we'll get from the course. Let's see. So as you might already know, this is going to be a 10-week online program. It's going to be designed for software developers, technology professionals, data scientists, data analysts, and ML professionals. With an understanding of computer vision concepts, tools, and techniques. The program is also going to explore some real-world applications of this technology, and you'll see it appear in the class in several places. Okay, so in this program, you are going to implement many fundamental image processing methods, and you're going to learn about various techniques or various applications that they're going to be useful for. We're going to use neural networks and learn about neural networks and see how they can be used for image recognition and for classification. We're going to learn about extracting 3D information from images, and we're going to learn the basic principles of geometry of a single view perspective and multi-view perspective. And we'll also learn about aligning and tracking objects in video. Good. So as I mentioned earlier, this is a 10-week online program. So let's talk about the program curriculum. Right. So here are the list of the 10 modules that we're going to be covering. Just to go through this quickly, the first 5 modules you're going to see are going to be focused on visual cognition. So this topic of recognition from images. We'll give an introduction of computer vision in module 1, give a big picture of what are the different fields, what are the different areas. And then we'll start talking about the digital image processing pipeline. So that'll be taught by both me and Giannis. Module 2 to 4, I'm going to be teaching those. We'll be talking about basic image processing. This is going to give us the fundamentals of how to work with pixels and how to filter them. Module 3 will be feature detection and matching. So this is kind of moving up in abstraction. Module 4 will be image classification and neural networks. And then module 5, we're going to cover convolutional neural networks and explain how they kind of encode all the things that we've learned from module 1 to module 4. After that, we'll go to module 6, talk about geometry, so transformations and homographies. Module 7 will be about camera models. You're going to learn that a camera can be expressed as a matrix, for example. Module 8, we'll talk about geometry-based vision. Module 9 will be working with motion. And then module 10 will end with physics-based vision. So let's dig into each of these modules a little bit more, and so I can kind of give you an idea of what we're thinking as we design this course and some of the topics that we'll cover. So in module 1, like I said, this is going to be an introduction to computer vision. The idea here in the first half of this module is to let you understand how big this field of computer vision is. You might only know one or two, just a few areas maybe that have been in the media, but really computer vision has been developed over decades, and there are many, many facets to this. So we'll talk about that and give you the big picture. And then I'll also try to connect this a lot to many real world applications. So that'll be the first half of module 1. In the second half, I'm going to ask Giannis now to kind of explain what we're going to cover in terms of working with digital images. So Giannis, you want to say a couple words on that?
Yeah, exactly. So the second half focuses briefly on digital photography and the image processing pipeline. And we'll go over some basic principles of how modern cameras capture photos of the real world. And second, we'll go over all of the sequence of steps that take place inside the camera, converting the measurements of a sensor to the final PNG or JPEG image that you are getting out of the camera. And understanding all of these steps is very important, not only for making your own photos better, but also for informing the decisions you're making when you design computer vision algorithms for extracting information from these photos.
Great, thanks, Giannis. Okay, so after that, we're going to move into module 2. So this is where we start talking more about image processing. You're going to learn how to describe the basic principles of image processing. So that's kind of carrying over from module 1. And you're going to learn different techniques for image filtering. So we'll learn about like the box filter, Gaussian filter, and making image pyramids and so on. So this will give you the basic knowledge of how to work with images. Then we're going to move on to Module 3. Module 3 is going to be focused on feature detection and matching. So feature detection and matching is kind of the bedrock of a lot of recognition tasks. It's also the bedrock technology for like robot localization and emotion understanding. So we're going to explore the essentials of feature detection. And what does it mean to find a good feature in an image and how to represent them? And then we're going to use these methods to build and train algorithms to detect corners and to visualize quadratics in images. Good. And then moving on to Module 4. Again, we're kind of moving up here in this level of abstraction. We're going to talk about image classification and neural networks. So we'll discuss a little bit about what does it mean to create an image representation. So how should we represent an image? We'll learn about something called a bag of visual words. And you'll see that the concepts that we learn here are going to be central to almost everything else we do in the other visual cognition modules. You will learn how to use a neural network to classify images, and we kind of have a fun programming assignment prepared for that. And then we'll move on to Module 5. So this will be the last module that I teach, where I'm going to be talking about convolutional neural networks. So I'll describe to you some of the basic architectural components of a CNN. And then we're going to learn how to use a convolutional neural network to recognize objects in an image. So the assignment that we have prepared for you is going to be digit recognition. So that should really give you a lot of hands-on experience working with a convolutional neural network. Okay, and then at this point, I'm going to pass it on to Yannis, who will cover the remaining modules.
Great, thanks, Chris. So the modules 6 to 10 shift attention away from learning-based techniques and cognition-based techniques for computer vision and focus on other classes of techniques that are based on geometry, physics, and motion. We start with module 6, where we go over details on how to compute transformations from one image to another, how to model these transformations in mathematically tractable ways, and how to also estimate the transformation we need to apply to change one image to look like another. And we'll focus especially on computing a special kind of transformation called the homography that is an important building block for a lot of applications such as augmented reality and virtual reality applications. Next slide, please. Then we'll continue with geometry, and we will study how a camera maps 3D points in the world to 2D points on an image. And understanding this kind of mapping is very important for learning how to do the inverse process of going from 2D images to 3D images, which will be the focus of the next module. So in the process of learning this, we'll understand all of the different parameters that affect how the projection from 3D to 2D is affected by different parameters in the camera, as well as we will learn how to figure out exactly the parameters of a camera based on different types of image measurements, a process called geometric camera calibration. And again, geometric camera calibration is a very important building block, a very important procedure in a lot of modern computer vision algorithms, in robotics applications, and so on. Next slide, please. So in module 8, we'll put everything we learned in module 6 and 7 to use to figure out now how to start doing 3D sensing. And we'll learn how, by having multiple images of the same scene, at least 2, potentially more than 2, how to extract from them 3D information about what is depicted in the scenes. So for that, we'll go over algorithms such as binocular stereo, disparity-based stereo, and different pipelines that form that are nowadays used for stereo applications such as autonomous vehicles, robotics, and so on. Next slide, please. Then in module 9, we'll switch over from processing static images, which is what we have focused on in pretty much all of the previous modules, to now processing videos, sequences of images, where we see the motion in a scene, how different objects move, how potentially our camera moves, and so on. So we'll learn how to model the motion that we observe from one frame of a video to another, an idea called the optical flow. And we'll also see how to come up with algorithms that allow us to track specific objects across a video so that we can, for example, run on them some recognition algorithm or some other downstream computer vision algorithm. Next slide, please. Hello? All right. So in the last module, we'll go over some physics of the image formation process that converts the light that we see in a scene as a function of light sources, material parameters, and so on, into the intensities that our image capture. So we learned some physical fundamentals for how this mapping from scene parameters to image intensities happens. And then we'll learn algorithms for inverting this image formation process so that we can extract from images very detailed shape information or very detailed material information. And the physical elements we'll see here are in the basis of modern algorithms for neural rendering and inverse rendering reconstruction, such as NERF, implicit differentiable surfaces, and so on. And I think that concludes all of our modules. I'm going to pass it on to Marie.
Thank you so much, Professor Goulekas and Professor Catani, for taking us through this detailed module overview, helping to describe some of what students will be learning and those high-level learning objectives from week to week, as well as who is the program designed for. So absolute honor learning more about this program from both of you. Our professors are going to be staying on the line with us today and all the way up through the end of our session. But now we're going to shift over to the how of the learning experience. So you've got that understanding now of what you'll be learning, and now we're going to shift over to how this curriculum is delivered. And you can see here some of these key areas that we've called out for you on the screen. Office hours with learning facilitators. And I want to stop and just take a moment about to describe these learning facilitators. I'm going to highlight that for you here. Our learning facilitators are industry experts. So they have been selected to come into this program and guide your day-to-day experience. So they're giving you individualized feedback on your assignments. They're hosting office hours, which is our chance for you to get your questions answered. And they're on the discussion boards with you and your peers, helping to push engagement, push your thinking, and keep the learning active and alive throughout the time in the program. So the learning facilitators are a key part of your teaching and learning team. If you're like me, I'm a visual learner. I like to think about things in graphs and images. They help me to understand it better. And I like to think about this program as different concentric circles of teaching and learning. You have yourself at the center as an individual student with your own learning objectives. A layer beyond that, you have your peers. And of course, your peer learning is allowing you to not only see these concepts come to life in the work that you're doing in your industry, in your geography, but you're also able to see these themes come to life in a more broad and expansive way as you're learning from your peers. So you have that broad tapestry of understanding as you see these themes come to life in other industry areas and other professional roles and with other perspectives. So we've built in a lot of opportunity for you to learn from one another. One of the ways that we do this is during office hours with learning facilitators. We also have discussion boards and other opportunities such as this one here for you to be live together with your cohort. Throughout the program, there are assignments, recorded videos, knowledge checks. These are all activities that we call bite-sized learning. So this is a learning pedagogical approach called bite-sized learning. And it describes the ways in which this course allows you to fully immerse yourself in the learning experience as you go. So for example, you'll watch a brief video segment here, and then you'll be able to step away, take part in some discussion boards, exercises, assignments, knowledge checks, really fully simmer and immerse yourself with the concepts learned there in that video before then moving on to the next. So this is a way that you can self-pace your educational experience, really fully immerse yourself as you go. And this pedagogical approach works really well in the online learning space. So a chance for you to really take it as you go. All of this, we talked about yourself as a learner, your peers. A layer beyond that, you have your learning facilitators. A layer beyond that, of course, you have your program faculty who you heard from here today. A layer beyond that, Carnegie Mellon. We learned more about the mission at Carnegie Mellon. So all of these different communities of teaching and learning and relationship building folding together throughout your time in the program. This is all contained by a 24/7 dedicated program support team. So any technical issues or needs that you have, any requirements in the program or questions, you have a support team at the ready to help assist you. So these are the things that you can expect in terms of the course delivery. Our program support team are here with us now on the line. I'm going to be introducing them to you here in just a moment, so stay tuned for more about how to get connected with an academic advisor. This is another opportunity for you to have your learning formalized here in this program. So in addition to the knowledge and the frameworks that you'll be taking away from this program, you'll also have an opportunity to earn a credential here from Carnegie Mellon University School of Computer Science. You'll see here, this is signed by Ram, the Director of Education, Executive Education, as well as your course professors, Gulekas and Ketani. So a chance for you to, again, formalize your training. And for those of you looking to springboard into career advancement opportunities, certainly having a credential here from Carnegie Mellon University will go a long way in helping you to achieve those goals. This is our last and final slide here, and this is where I tell you more about how to get connected with a program advisor. So our advisors here are the course foremost experts when it comes to all of the logistics for the program. Some of those logistics are outlined for you here, and I'm just going to highlight that for you here. It's a 10-week program. We estimate 5 to 10 hours per week. So as you're thinking about logistics, as you're thinking about designing a schedule that works for you, this is your target across these 10 weeks, is really to identify that 5 to 10 hours that should be devoted towards your learning in the program. Now, if you'd like to speak with an academic advisor about those logistics, perhaps you're wondering, when are the live synchronous learning sessions? What time zone are they in? How can I best describe those 5 to 10 hours of video content versus assignments versus peer interaction? If you'd like that layer of detail understanding, we encourage you to get connected with one of our program advisors who's here on the line with us today. Not only can they help you with the logistical information, but they'll also be able to assist you with any course policy questions that you have. For example, what is my alumni access after entering this program? Or how do I earn that certificate of completion? What's the evaluative criteria for the program? What happens if I'm late with an assignment? These are all sort of course policy questions that your advisor can walk you through. And then finally, the registration and enrollment process. They are best positioned to help you explore financing options, special group enrollment pricing, flexible payment options. They're going to be able to help you with all of those kinds of questions related to getting prepared for the logistics of the program, understanding the course policy, and getting registered and enrolled. So we talk a lot about the relationships that you build in this program, the different layers of teaching and learning. We want that to start right here, right now on today's session by getting you connected with an academic advisor. They're going to be your first person to help get you prepared and sorted as we reach that December 2nd date. So how do you get connected with an advisor? There's a couple of different ways. You'll notice on your screen here, there's a picture here of our course enrollment page. We invite you to go over to our course enrollment page. We're going to post that here in the chat here in just a moment. But if you go over to the course enrollment page, you can click on that black Apply Now button there, and it will invite you to put in your contact details, your name, email address, and phone number. And as soon as you get those contact details into the form, the very next thing that will happen is a program advisor who's here with us on the call today will reach out and get connected with you. Now, if you're not quite ready to go over to the course enrollment page, you'll see the link there at the bottom of your screen. We're also going to be sharing today's recording with you. So we recorded today's session, and we're going to be following up within 24 to 48 hours to provide you with copies of not only the recording, but all of the slides that we've covered here as well. So once you receive a copy of the recording and the slides, you can go over to the course enrollment page using the link here on your screen, or you can simply reply all to that email and let us know you need an advisor, and we will get you connected with someone who can help support you between now and December 2nd. So a lot of different opportunities for you to get the support that you need. I'll start us off here with a question about prerequisite knowledge. Professors Katani and Gulekis, when you designed the program, you shared a slide with who is the program designed for. Is this program for beginners who are just starting out, or is there a certain level of prerequisite knowledge that you would recommend?
I can take that, Chris. Yeah, it's a course designed for beginners in computer vision. Really, the prerequisites would be experience programming in Python and some basic knowledge of linear algebra and maybe probability and statistics, but very basic knowledge. And we cover most of the background needed from these areas in the course.
Thank you for clarifying. And in terms of the industry that you had in mind, computer vision, this really spans across industries. Is this meant to be the type of program that can relate to many different kinds of industries and professional roles, or did you have a certain subset of industries in mind?
Sure, I could take this one. So I think that the topics that we cover are pretty broad in computer vision. So it's going to give you a nice understanding of the field in general. So because of that, I think it's going to apply to different industries wherever you are. I mean, even if you're not using it at the company that you're in, you might be interacting with companies that are using computer vision. So I think that's the kind of knowledge that you'll get from this course. So to give you a nice, I think, big picture, hands-on experience, but it'll give you a big picture. And I think that's a part that's going to be really valuable.
Right. Yeah. Thank you for drawing that distinction for us. I think we've done a pretty good job of describing the program here and its key features. So we'll go ahead and close out the session a little bit early here today and say goodbye. Any final thoughts, words of wisdom? Maybe what we'll do is we'll start with you, Ram. We'll go over to you, Giannis, and then finally, Chris. So any final words of wisdom that you'd like to share with folks who are considering joining the program here on December 2nd? Ram, over to you.
Not sure about wisdom, but because I'm not the professor. But in terms of the rigor of our program, we've designed this course. It took us a good 9 months to design. It is as rigorous as the programs we have on campus, but it is geared towards working professionals. So you're able to accommodate this course into your working schedule and still gain the knowledge that you need, and you have the support ecosystem both through various online collaboration methods, and most importantly, we have this live office hours where you're able to come and get any questions you have about the content or the assignments answered. So you should take advantage of that. Over to you, Giannis.
Yeah, thanks, Ram. To add to what Ram said, I think that an important feature of the course are the programming assignments we have put together, which are really designed to make sure that you get to practice the stuff that we cover in the modules, and you get to implement on your own a lot of important computer vision algorithms that are used again and again and again and again, not just in research, but also in industry and all of the commercial products available nowadays that use computer vision. So hopefully through the programming assignments, we'll get all of the engineering skills necessary so that we can have some working knowledge of computer vision for whatever you use it next. Chris?
Great. Yeah, so this is advice I think I give to all of my students when I teach every semester is, whenever you take the course, really take that perspective of trying to master the material. So make sure that you have enough time to invest into this and really dive deep into the topics. I think this course has been set up so that you have like discussions, you have assignments, you have these interactive kind of like quizzes that you can take to really help you reinforce your understanding, but really take that extra step to dive in deep. And then I think what you'll find is that you're going to have a really solid and kind of confident understanding of computer vision, and it's really going to open up a lot of opportunities to you. So that's my main advice. Yeah, just master the material, dive into it, enjoy it, and it's going to have a huge impact on your future.
Thank you for those words of wisdom, those words of advice, Professor Gulekis, Katani, of course, Ram, thank you as well for being here. And to all of you who've joined in from across the globe to be here with us today, absolute honor learning shoulder to shoulder with each and every one of you. We hope to see you all back in the program beginning on December 2nd. And with that, we sign off with a heartfelt good morning, good afternoon, good evening, and good day to all of you from around the globe. Thank you again for joining, and we hope to see you soon in the program. Bye-bye.
Thank you.
Thank you, everybody.